What's going on, guys? My name is Suboptimal and I'm just your typical Indian software engineer. Over the past few months, I've made tons of videos going over various topics in Three.js, but more and more recently, I've become very interested in a specific part of 3D graphics called shader programming. The typical example that I always like to showcase is this one right here from Minecraft. On the top left, you've got the shaders enabled, and on the bottom right, you don't have shaders. And clearly the top left one looks a lot better because you've got lighting reflecting off of the building, you've got clouds, you've got a little bit of fog. Basically, shaders add a lot of depth to your 3D scenes. And in this specific shader tutorial, we'll go over the theoretical concepts of Phong lighting and implement them in a GLSL fragment shader. Essentially, our goal is to add lighting and transform the duck model on the left side into the one on the right. The code for this project, along with the instructions about the VS Code setup, can be found on my GitHub. And before we get started, I'm just going to ask for one small favor from you guys, and that is to hit the like button for the YouTube algorithm. Cool. With that out of the way, let's jump right in. A huge part of computer graphics is about making objects look 3D on a 2D screen. Lighting is one of the best ways to do that. And Phong lighting specifically is a common lighting technique used in computer graphics to convey the 3D look and feel of objects. Here you can see Phong lighting being applied to two different types of objects, and basically it comes down to three main components. Phong lighting is made up of ambient light combined with diffuse light combined with specular light. To get some more intuition behind how this lighting method works, we're going to take a look at these three diagrams. The way I like to think about ambient light is if you've ever sort of woken up in the middle of the night, you'll notice that you can't really see anything. And then about 30 to 60 seconds later, you can start seeing things more clearly. That is because your eyes have started taking in more light and allowing you to see the ambient light of that scene. Even though you have no lights turned on, you have some visibility about the objects around you. And that is what ambient light is supposed to replicate. The next set of light is diffuse light. Now, diffuse light requires you to have a light source. And then based on where that light source is located, you're going to apply reflection on the object and give it a little bit of a 3D feel. And finally, specular light takes into account the light source as well as your current view direction. So where are you looking at the object from? And using those two main vectors, you can figure out how to apply the specular light. And when you combine all these three together is when you get Phong lighting. Cool. With those basics out of the way, let's jump into the code. There's only one thing that we currently care about. I've commented out everything inside of the code, and all I want you guys to focus on is this piece right here. Lighting is equal to the ambient light plus the diffusion light plus the specular light. Right now, all I'm setting that to is completely black. The color of this entire model is going to be the base color of the model times the lighting. That's all you got to focus on. So I'm setting the base color to be some sort of mix between gray and white. So it's going to be some grayish color, and the color is going to be the model color times the lighting. So you can see here on the right side that the duck is completely black. Now let's add ambient lighting and see how that changes things up. Ambient lighting is just very simple. It's just the base amount of light that exists for a specific object. And here I am saying that the base amount of ambient light for this object is 0.5, is just right in the middle. And now we're going to go down here and set the lighting equal to the ambient amount. And we're not going to change anything else here. And if we save this, you'll see that this is the ambient light of this object. The diffuse lighting is going to take into account the normal vector and the light source. So wherever the light is perpendicular to the object, we're going to have the most amount of reflection. So it's going to be super bright there. Wherever it is a little bit curved, it's going to have a little bit less light. And wherever it is almost perpendicular, it's going to have no light. Let's see how to implement that in the code. Now, first thing that we need to think about is the normal. So the normal is a variable that is usually passed in from the vertex shader. Because we're mainly working in fragment shaders here, we can just assume that it gets passed in. We need to think about the light color as well as the light source. Right now, the light color is going to be white and the light source is going to be at x equals 1 y equals 0, z equals 0. So it's kind of weird to look at these like they're both vec3s, right? But we're saying that this vec3 is going to be a color and this one's going to be a coordinate. Now the next important step here is the dot product. This is the real meat of the function here, is we're going to take the dot product of the light source with the normal of the specific object. And of course we want to say that the diffuse component of this lighting is equal to the diffuse strength times the actual light color. And the last thing I'm going to do here is set lighting equals to ambient times 0 plus diffuse. So let me save this, and there you have it. You've got your diffuse light, and it is basically starting at some point over here, and it is lighting like this. And yeah, that is diffuse lighting. And the last thing to talk about is the specular lighting. Now the specular lighting takes in a couple of variables, right? We're going to have the light source and our view direction. And in order to calculate the specular lighting, we need the reflection vector. Fortunately, in GLSL, there's a function called reflect, which takes in the negative light source and the normal, and it basically gives you this vector out of the box. So remember that we need the view source wherever we are currently viewing it from. And now this is something that I am sort of setting in place here. We are looking at this duck from 0, 0, 1, which means that our x and y coordinates are 0 and our z coordinates is like 1 toward the screen. And now we can get the reflection source based on the negative light source and the normal. So the light source here is actually coming in from the same light as the diffuse light. I mean, I could redeclare it and have like light source 2 and put the same variable here, but that's just a bit more code. So I want to simplify it and use the light source from here. Then that'll give us a reflection source. And then we can calculate the specular strength pretty easily. All we have to do is take the view source, like where we are currently viewing it from, and do a dot product with the reflection source. One more thing is, you're going to want to increase the specular strength to a high power to give it a lot more shininess. And I'll showcase what this does in a bit. So let's do this. And of course, in the lighting section, let's set ambient to 0, diffuse to 0, and just do specular to see what it looks like. And so here you get the specular sort of glossiness of that specular light. Now let's take a look at what happens if I don't do this, right? So basically, the higher the value here, the more like glossy of a look that you get. And so putting something like 64, you'll get like this super shiny glossiness to the object. And now let's keep it pretty simple and go all the way down here. And here what I'm setting the lighting to is 0.5 times the diffuse plus 0.5 times the specular. I'm just going to remove the ambient light because I think that actually it makes it more confusing to understand lighting. And the last thing I want to do is increment this to 1.0. So we get a little bit of better lighting so you can actually see that and it's visible. Now that we have these lights in place, let's just sort of move things around and see what happens. So suppose I move the light source for both the diffuse and the specular light to be 1, 1, 1. So let me save that. You see, you get the lighting from the top right side. Suppose I say that the light color is now, instead of it being white, let's make it red. You get red lighting. Now suppose the lighting is white and the actual model color is now green. So we're going to set 0 for the red section, 1 for the green, and 0 for the blue. And boom, you get the model now is green and the lighting is technically white, but it's sort of reflecting off of the green model. And yeah, you can sort of play around with these lights and see what happens. By now, you should have a good idea of how Phong shaders work and also how to implement them in GLSL. If you've made it this far, then I'd really appreciate it if you could just hit the like button and consider subscribing for more tutorials on GLSL shaders. Thanks for watching, and I'll catch you guys next time.